Okay, this is the Unit 5, Algebra 2 review. Starting with the first question says, classify this function by degree. So we always want to look to see what the highest degree is. Notice this is not in standard form, so I'm looking through finding the highest degree. 5 is the highest degree, so that is a quintic. Okay, remember that if the highest degree is 2, so like x squared, that would be quadratic. X to the third, the highest degree is 3, that's cubic. And then x to the fourth is quartic. Okay, so again, we're looking for the highest degree. So the highest degree for this one is 5, so that is quintic. Let's look at the next one. Okay, it says sketch a graph that would have the end behavior of a polynomial function with an odd degree. Okay, if you remember, if we have an odd degree, that means that we have different end behavior. Okay, so different end behavior. So it could look something like this. Different end behavior. So this end is going to negative infinity, this one's going to positive infinity. So different end behavior. For some reason I skipped number 2, so let's go back up. Circle each of the following graphs that are graphs of polynomial functions of an even degree. Okay, so we just talked about how it's going to have different end behavior if it's odd. So an even degree, so even, so notice that this is going in 2 different ways. The ends are, one's going to positive, one's going to negative infinity, so that's not one. This one, both of the ends are going to negative infinity, so that has the same end behavior, so that's even. Okay, this one has opposite, this one has the same, and the last one has the same. Okay, so even, same end behavior, odd would be different end behavior. So let's look at number 4. Consider y equals x to the fourth graph, y equals x minus 2 quantity squared plus 1. Okay, so in order to do that, we can put that in our calculator. But before we put it in the calculator, you should remember that for transformations, this plus on 1 on the outside means up 1, and then the negative 2 on the inside means to the right 2 because of insiders lie. And then we see that it is a quartic function. So you should be able to graph it, but if you're unsure, then go ahead and put it into the calculator. So I have x minus 2 to the fourth. Make sure you arrow out before you put your plus 1. Zoom 6 gives you the normal viewing window. So I know that I went to the right 2 and up 1. And notice that this kind of looks like a quadratic, except it's a little flatter at the bottom. You could actually plot some points as well to get a better picture. So go ahead and plot that and sketch that out. All right, hopefully your graph looks a little better than mine. All right, if we look at the next one, first try to see what the transformation is before you put it in the calculator. I have cubic, okay, and I see this negative in front means that it's going to be a reflection over the x-axis. The plus 4 means to the left 4, and the minus 2 means down 2. Okay, so you should be able to go ahead and sketch that. You can also double check it in your calculator. Okay, there's your graph and there's your sketch. Don't forget you can go into the table and find your points, but this right here, we know we went to the left 4 and down 2, which is going to give us that point right there, and it is a cubic function. All right, let's go on. Okay, so the next one say identify the transformation. There are 3 transformations for each question. So very similar to what we were doing up there. So 3 transformations. So I'm going to do each with a different color. I have a transformation here. I have one here. And then I also have one here. So those are my 3. Okay, so the 3 in front means a vertical stretch. By a factor of 3. Okay, so the next one, we know plus 57, which is a lie, so it's going to the left 57. So left 57. And then negative 392, so down 392. Okay, let's go to the next one. So again, I have a transformation here, here, and here. So the first one is a flip or reflection over the x-axis. Negative 78 means to the right 78. And then the positive 876 means up 876. Okay, last one. Again, transformation here, here, and here. So again, I have a reflection over the x-axis. We're going plus, so we're going to the left. And then minus 74, so we're going down 74. Okay, remember that all originates from y equals plus or minus a times x minus h plus or minus h plus or minus k. Okay, so that works for anything. Remember, plus or minus, the minus is a flip over the x-axis. A can be a vertical stretch or compression. H is left or right, but if insiders lie, positive is going to be going left, negative is going to be going right, and then plus or minus K is up or down, up being positive, down being negative. So that's where those originate from. Let's look at the next one. Circle the graph of the function x cubed plus 1, okay? You should know what that looks like immediately, but if you don't know, put it in the calculator. So x to the power of 3 plus 1, zoom 6 gives you your normal viewing window, and we see that this is the correct answer. Okay, next one says consider the parent function x cubed, which equation shows a shift to the left 2 units and down 7 units. Okay, so to the left 2 units, so that has to be on the inside of the parentheses. So the left 2 units. Remember, insiders lie, left would take you into the negative, but it's lying to you, so it's plus 2, and then we have down 7 units, so down 7 units. And then x cubed is going to go right there. So if we look here, that's to the right and up, that's to the right and down, that's that's to the left and down. That's the one we want. This one right here is to the right and up, and this one right here is to the right and down. So this is the one that we want. We want to the left 2 units and down 7 units. All right. Okay, so the first question says select the domain and range of the function shown. All right, so if I look here, we want domain and range. So domain is all my x values, so starting from the left. Okay, remember that this graph is going to keep going on both ends. So it includes negative infinity all the way to positive infinity. So I know domain is negative infinity, positive infinity. Let's try my range from down. So this is going down still, so negative infinity, and it's going to keep going up. Negative infinity to positive infinity. All right, let's look at our choices. It says domain is x is greater than or equal to 1. Range is y is less than or equal to 2. Nope. Greater than 0? No, because I have negative numbers. The domain is all real numbers. That's true. But the range is greater or less than or equal to 2, which is not true because we, again, should have all real numbers. So the last one, domain is all real numbers. Range is all real numbers. Remember that we could also see all real numbers written like that as well. Number 12, given the domain is all real numbers, what is the range in interval notation of the function f of x equals negative 2x to the fourth plus 4x squared plus 3? Okay, so we can put that into the calculator, into y equals. Okay, so we should know from the negative sign in front here that it would be pointing down. The end behavior is to negative infinity, and because it's even, it's negative infinity on both ends. So, and if we put that into the calculator, we see that it is going to be from negative infinity, and then you want to know where that maximum point is, as far as it'll go. So, okay, so if we do the maximum there, I see my x value is negative 1, but they only want the range here, so the highest the range will go is 5, and it doesn't include 5, so we're going to close the bracket there. All right, describe the end behavior of the function y equals negative x to the power of 79. Notice that this is an odd function, so I know that I have opposite end behavior. And then I see that this is negative, which means that on the right-hand side, it's going towards negative infinity. And on the left-hand side, which is the opposite, is going to have positive infinity. Okay, so that's a negative in front is going to tell me that on the right-hand side, I'm going towards negative infinity. And I have opposite end behavior, so going as x approaches negative infinity, then f of x has to be approaching positive infinity. You can double check that in your calculator. And the calculator doesn't really like that very much, and it looks pretty funny, but you can kind of get the point here that as x approaches positive infinity, notice the line here is going down, it's going to negative infinity. As x approaches negative infinity, it's moving up, so f of x approaches positive infinity. All right, the next one says describe the end behavior of the function. All right, so again, we see that this is a even number, which means that we're going to have the same end behavior. And then in front, I have a positive, which means on the right, I'm going to positive infinity, and same end behavior. So as x approaches positive infinity, f of x approaches positive infinity. And as x approaches negative infinity, f of x approaches positive infinity. Okay, again, if we went ahead and graph that one, you would see that, again, as x is approaching positive infinity, f of x is approaching positive, as x is approaching negative, f of x is also approaching negative infinity. Okay, so the next one, it says identify the maximum, the minimum, and the intervals in which the function is increasing or decreasing. All right, so we have a minimum here. So that minimum there is at 0, negative 3. Okay, so that's a minimum. And then it says to show the intervals of increasing and decreasing. So I like to highlight, so here is decreasing. So this is decreasing. And remember, we only care about the x values here. So I'm decreasing from negative infinity. And I stop decreasing right here at this point, which is 0. So decreasing from negative infinity to 0. Okay, and then I'm increasing. It slows down here, but I'm still increasing. So I'm increasing. So I'm increasing here from 0 to positive infinity. We said that we do not, our minimum was 0, -3, and there's no local maximum. All right, and then the last one says given the graphical characteristics for the following, give the graphical characteristics for the following graph. So let's start with the function family. This is a polynomial function. And if you look here, if you're unsure how to spell polynomial, okay, classified by degree. So let's look at the turning points. I have 1, 2, 3, 4 turning points, which means that if it has 4 turning points, that has to be x to the 5th. Well, x to the 5th, classified by degree, we call that quintic. Okay, domain from left to right is going to be -infinity to positive infinity. Range going down to up, it's going to be -infinity to positive infinity. Okay, so increasing and decreasing. So let's do all of our decreasing first. See that I'm decreasing from here to here, here to here, and here to here. So decreasing, 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 increasing, from here to here, and here to here. Now, my suggestion here is to go ahead and label each of these maximum and minimums, because if you do that, then you'll know the x values that you're going to need. So go ahead and label each of these vertices. So I have this first one is -1.5, comma, -3.5. Up here, this is -0.5 and 1.5. Here is 2, 0. And here is 1, -4. Okay, and remember when we're doing decreasing and increasing intervals, we're only looking at the x values. So let's start here. We're coming from the left. We said this was decreasing, so -infinity to this x value. So decreasing -infinity to -1.5. Union with, I only want decreasing, so x values only, -0.5 to 1. Union, I have another decreasing, only x values, 2 to positive infinity. Because it's going to keep going out here, and it's always decreasing on this side. All right, so then we have increasing. So I have increasing from, remember we're dealing with x values, -1.5 to -0.5. Union, increasing again from 1 to 2. And these should all match up, like the union, the pieces that are missing. So when I'm not decreasing, then I should be increasing. Let's keep going. The zeros. So the zeros are the x-intercepts. So I have an x-intercept here, 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 and here. So my x-intercepts, we say x equals, so x equals -2, -1, 0. And remember that this is a double root when it bumps up against the x-axis right there. So we have 2 and 2. Okay, the x-intercepts. So same thing, except we list them in order pairs. -2, 0, -1, 0, 0, 0, and 2, 0. The y-intercept, so the y-intercept is right here. And the y-intercept is 0, 0. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay, asymptotes, there's no asymptotes, so we're going to write none. How many turning points? We actually figured that out a few minutes ago because we were talking about the degree, so 4 turning points. The local maximum, so I have 2 local maximums. I've got a local maximum here and a local maximum here. So negative 0.5 and 1.5 and 2, 0. And then minimums, I have a local minimum here and here. So negative 1.5 comma negative 3.5 and 1 comma negative 4. And then in behavior, as x goes to positive infinity, so as x goes to positive infinity, what's happening down here? It's going to negative infinity. And then as x goes to negative infinity, f of x goes to positive infinity. That's it for the first video.